Assalamualaikum warahmatullahi wabarakatuh. Hello guys, welcome back to me, Farhan Hafid Setiawan, and I'm from class of Numeric Method 3, and my NCPN is 22068248110. And this video, I'm gonna teach you and I'm gonna explain about my perspective to optimize the numerical method with the 5 in engineering problem. Okay. Before that, it's my uh, let us consist about uh, myself and to myself or ourselves to fully to take the God in hands to for the goals in study about optimized numeric method. Okay, let's go to the video. The first thing first, I'm gonna explain about intentions at our goal that focus you that I'm focused to solve about numerical method optimize that the goal of this project or videos is to optimize the storage of hydrogen a green energy carrier for efficient and cost-effective use in various applications such as transportation, power generation, and industrial process. Hydrogen storage is a critical component that transition to low-carbon economy, and optimizing its storage can significantly reduce the overall cost and environmental impact of hydrogen-based systems. Okay, for this optimize, I get the reference from the exercise uh, based on the 2021 numeric method class. But in this case, I'm gonna modify to optimize hydrogen storage in use to car hydrogen. Okay, you gotta mention that I don't uh, do the same thing as my seniors do on the last year, but today I'm gonna make the optimized storage hydrogen focus on hydrogen car. Okay. Now let's go to the initial thinking. That initial thinking is that the goal of this project is to optimize the storage hydrogen. Uh, okay. Samely as the intention before. Then in the initial thinking, I we got the three objectives that you're gonna reach. That first is to maximize the storage capacity to increase the storage capacity of hydrogen while minimizing the required space and cost. Secondly, you're gonna improve your safety by develop a safe and reliable storage system that minimize the risk for accidents and ensure efficient operations. And last, you're gonna enhance energy efficiency. Optimize the energy efficiency of hydrogen storage system to reduce energy loss and costs. Okay, the idealizations. The first is define the requirements. They determine the specific requirements that hydrogen storage need and consider the application and constraints such as space limitation or weight restrictions. Secondly, evaluate storage methods that explore the driver have hydrogen storage methods such as compressed gas storage, cryogenic storage, metal hydride storage, or chemical storage. Third, analyze system efficiency. Energy loss during storage and retrieval, the energy requirement for compression or cooling, and any potential degradation over time. Four is perform modeling and simulations. Use computer-aided modeling and simulation tools. Uh, in these situations, I use the Google Colab or basically the coding runner from the Google to simulate the behavior hydrogen storage system. Five is material selections. If you choose a specific storage method like a metal hydrogen storage, you need to select the suitable materials too that can absorb the release hydrogen efficiently. Six is safety considerations. To ensure the safety measures are incorporated into storage system design. Uh, Example is hydrogen is highly flammable or some things that for the purpose safety. Okay. Seventh is cost analysis. That perform a cost analysis to determine the economic feasibility of the optimal storage system. And last, the optimization of iterations that iterate the design and optimize process based on the result or testing and cost analysis. Okay. There in this video, I focus on hydrogen car specifications. And hydrogen storage in hydrogen car is typically involved with use compressed hydrogen tanks, type which are designed to store hydrogen gas at high pressures. Here are some key specifications related to hydrogen storage in the car. The first thing first is pressure. Hydrogen storage tanks are designed to operate pressures ranging from uh, 350 to 700 bar. Higher pressures allow for more hydrogen to be stored in a given volume. Secondly is tank materials. The tank is typically made of carbon fiber composites or carbon fiber and metal alloys with a high molecular weight polymer in it. Inner line, we need prevent hydrogen gas permutations. Third is tank design. That the tank design is withstands the high pressure and I often shaped to optimize storage capacity while minimizing weight and volume. For example, when we use thick-walled tanks that are particularly safe and have been validated through crash tests. Because uh, the hydrogen is very dangerous if you don't mention the safety on the first place, because it can burn and flammable. Fourth is storage capacity. The storage capacity of hydrogen tank varies depending on the design and materials used. For example, a study of hydrogen storage for a fuel cell vehicle found that hydrogen storage at the 700 bars in type of 3 or type of 4 vessels offers a practical solution with a refueling of less than 3 minutes and driving range of 500 kilometers. Lastly, the safety measures that include the features such as pressure regulators and in-tank in-gas temperature sensors to monitor the tank internal conditions. Okay, we're gonna talk about material selections. That uh, there's four basic type to hydrogen storage tanks. The type one is all metal with 3000 psi or 200 bar with the differentiate or safety factor 2 or 3 at 100 bar. Okay. The tattoo made with metal with wrap and outer and inner with RP layer and can do take some 300 bar. Type 3 outer with a metal liner and the inner with RP layer can take some 700 bar in it. And then specification is especially lightweight. Okay, the lastly is the type 4, the made in plastic liner of our router, and the inner to take some KFRP layer that can takes 700 bar with no loading bearings, and especially uh, type is lightest. Okay, there are several materials commonly used for hydrogen storage is with it is advantage and limitations for each other, and the choice of materials depends on factors such as storage capacity, operating conditions, safety considerations, and cost. This is some of material used for hydrogen storage. There GTS, compressed gas storage, liquid hydrogen storage, metal hydrogen storage, and carbon-based materials. The explanations can you post to you can post the videos and read some explanations because it takes more time and I'm gonna do efficiently for the videos. Okay, last is about the instruction. The objective of this instruction is to optimize the design and operation of a hydrogen system to maximize the storage capacity, improve its safety, and enhance its energy efficiency. Okay, let's go to deeper about the design of hydrogen storage that I assume in these videos. Where this container design is designed in a cylinder container that is common to practical shape for pressurized storage. The dimension determine the container dimension based on desired volume and pressures. The container volume is fixed at 1 liter based on specification, and the pressure is 700 bar. The wall thickness calculate the required wall thickness using the below formula. T equals to P multiplied by D per 2 multiplied S, where the P is the pressure, specification is 700 bar, and D is the diameter of the container, and S is the allowable stress for HDPE, or in this case, or the carbon fiber composite too. Ensure the calculated wall thickness is within the manufacturing capabilities and budget constraints. Let's do some container design. The ADHP is commonly used material for various applications, including hydrogen storage tanks when designing the storage tank using HDPE. Material compatibility, HDPE is known as Exol's chemical resistance, including a resistance to hydrogen gas. It's important to verify the specific grade for HDPE, HDPE use and ensure its compatibility with hydrogen. The material supplier should provide information regarding the su- suitability of the HDPE grade for hydrogen storage. For inner material, we use stainless carbon fiber composite. The specification for the carbon composite used in hydrogens include a material selection of carbon fiber composite materials to their high strength to weight ratio and resistant to corrosion. The linear material used is typically aluminum alloy, uh, 6061 for type 3 and 4 vessels, while the strain enhancement layer is carbon fiber and epoxy composite. The operating temperature ranges between minus 40 Celsius and 50 Celsius, with a nominal operating pressure of 35 megapascal and a hydrostatic the pressures of 45.5 megapascals. Okay, there's some numeric method to um, involve some calculation about what should we use to, oh, sorry, what should we choose about how much is thickness HCB, what where are we gonna make. Okay. We used coding by Python. Sorry, I cannot give you exactly overall because it is point can do uh, nunjukin semuanya. The thickness HDPE based on calculation, the minimum thickness get 14.99 millimeter in this code. So we assumes that build strength of 22 megapascal for the HDPE and use safety factor of 2 for the design purposes. The calculate optimized thickness a function takes the volume and pressure as input and returns the optimized thickness in millimeters. Uh, Next, about geometric calculations. Radius and HDPE. In this code, we calculate the radius in the vessel based on the volume and the pressure using the formula derived from the cylinder volume equations. For the height is then calculated as at twice the radius. Both the height and radius converted to millimeters for display purpose. Based on this calculation, the height and the radius are 108, 39 millimeters and 54.19 millimeters. Simply, this code is based on the derived formula of the cylinder volume equations to get the height and radius per meter for the ACBE materials on their hydrogen storage that we're gonna use. Okay. Lastly, for the HDPE, we must use we must know some the surface area that we need with 700 bars and 1 liter capacitation. Okay, in this code, to the calculate surface area function, take the height, diameter, and thickness as an input. It converts the dimension to meters and calculates the inner and outer radius. The surface area is calculated by considering the cylinder sides, top, and bottom of the vessels. The total surface area is the sum of the areas of the inner and outer cylinder's surface and the top and bottom circular surface. Based on these calculations, the minimal surface areas needed is 70547.08 square millimeters. Okay. Uh, Next we gonna calculate the inner in their hydrogen storage, such as uh, carbon fiber, carbon fiber, composites materials. Okay. We're gonna use some same coding too that we assume that yield strength that we use is 100 megapascals based on journal for CFC and use a safety factor of 3 or design purposes. To calculate optimized thickness, function takes the volume pressures as the input and returns the optimized thickness in millimeters. Based on these calculations, the thickness of CFC is 1.26 millimeters. Okay, I think I put some wrong code unless before the video end, I'm gonna show about our code and to calculate some geometry calculations. Okay, sorry for the instruction. Okay, uh, next we're gonna calculate the radius and height of CFC or fiber, carbon fiber, uh, carbon fiber composite. Sorry. Inner height is the inner of the is the height of the H HDPE minus the 2.89 millimeter. This 2.89 millimeter is uh, the parameters that we use to base on journal that uh, hydrogen or diameters in their storage. Oke. Jadi 2,89 ini adalah parameter minimal yang dibutuhin buat sekiranya height dari CFC-nya itu terhadap si HDP tadi berapa gitu. Okay, because that we gonna minus 2.89 for the inner height and inner radius based on HDPE for new that CFC inner height and radius. Okay, we got that these parameters. Uh, we're gonna do the geometric calculation on surface area of CFC2. That basically same as the code we use to HDPE. For this moment, uh, do I put some parameters such as inner height, radius, and thickness that we got before for the surface area. Assume that we need to surface area of CFC. We got the area here in the vessels is approximately 23803.61 square meters. Okay. My conclusions is the geometric calculation is one of the numerical method applications or optimization about how to we got the especially what the kind of the kind of parameters that we're gonna before we're gonna make some hydrogen storage. Especially in this case, is based on the hydrogen car. I hope these things is can be useful uh, to us or to you if you wanna uh, make some hydrogen storage for the your thesis or some things. And I hope it's so. But before we close that, I'm gonna uh, show you about our coding to uh, explain to you that I not debug uh, the resume that my seniors do last year. There's a modification that this is for uh, thickness STPE. That's for the height radius and wall thickness to uh, HTPE. Then this is the surface area vessels. Sorry, this is surface area vessels for the STPE too. Tadi ada yang salah gambar. Ini gambarnya nih for CFC thickness in 1 liter capacity and 700 bar pressure spinels based on journals. Then the uh, surface. Okay, I think this is for me. If there are any word, if there are any suggest or the if there is suggest for me to be better in the next video, I hope you can comment and give your like for this videos. And that's it. Assalamualaikum warahmatullahi wabarakatuh.